Okay. Okay. All right. Um, all right. 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 Okay. Hello. Hello. Hello, everybody. Hello. How's everybody doing today? Hello. How's everybody doing today? I hope everybody's doing good. Hope we have some usual people here. Hopefully everybody's doing very fantastic. Oh, sorry for the little bit of delay here. I had a little bit of an issue. Just trying to work things out with the stream there. So not sure how much of a delay I have, but I was trying to get things to work out okay. You know, um, so you know how it goes. You try and make it look a little bit better. Hopefully, hopefully a bit better. Hopefully we got a few more people coming in. Know I started a bit late here, so I may start a little bit late. Yeah, that's just fine. So, um, talk about a couple things here. Some, that, uh, should be time to finish that. Hey, Elizabeth, how are you? I was good to see you. I was worried that this wasn't coming through. So I made a few tweaks to the stream here because I was having those issues with the paint tool and all that jazz. So hopefully that these tweaks will make it a bit easier of a viewing experience without crashing 3 times in a single stream. So yeah, it didn't work out so well this morning. And then I'm like, well, I need to make some more adjustments. So I did. Hopefully it's better. Question mark. I hope it's better. So, yeah. This thing needs to be turned down. Oh, okay. Turn this music. Yeah, the music's pretty loud. I ain't gonna lie. It's actually louder than I thought. I hope that's not too loud for you guys. So, all right, me turn that down. So I had to make adjustments here. All right, there we go. Now the music should be in the background where it should belong. Well, I don't know who else is here besides you, Elizabeth. Nobody else has popped up just yet, but I'll wait for possible confirmation. See how it goes. How's my day been? My day's been pretty good. Been a little bit busy. Got a. Oh, here we go. We got Nick. Hey, Nick. I'm at work today. I'm at work, but work today was. Work today was exhausting. Yeah, I can understand that, Nick. Completely understandable. Emma, hello. Hello. Good evening. Good evening / afternoon. Yes, the sun's still out. I don't know when. I don't know if Lee Wen is here yet, but hopefully she'll come on by. If she is here, then that's okay. But I do want to point out here that I did work over the weekend on the exam. The last exam, I haven't finished the final yet because I'm still whittling down questions. So there are quite a few questions, and I don't want to make it too large. So yeah, the final needs to be made up here and needs to be posted this week. So I know I said I would get it out on Saturday, but I've been having a tough time trying to get that done. So that's my fault though. But again, But the thing that about the final here that I will tell you, of course, is it'll just be exam questions. So all 3 exams will pretty much be on display for the final exam. So no surprises about where the questions will be coming from. They'll be coming directly from the exams. So nothing too crazy. How are you guys finding the work? Has it been okay? I know I made this last exam. There's like 55 questions, but some of them go by pretty quick. So, did you guys how'd you guys find the work? It's not too much. I know there's a lot of sections, but you guys okay with the homework here so far with the exams and whatnot? You guys gotta give me your opinion. You guys, I don't know what you guys think about that. So just let me know. I'll work with you guys. So you guys come in here all the time, and you guys let me know what's going on. So you know how it is. I'll let you know when to do. Okay, that's fair. When I get around to it, I'll figure it out. It's been good. Okay. So has the self pace been really good for you this semester? I felt a little conflicted on the self pace thing, but I felt it was the right choice considering it's summer. I felt it's usually a good choice even if it's not summer, but um have you been okay with the self pace there? You're a tad behind? How big is a tad behind, Nick? I don't know. Everything's going well? Okay, good. Emphasis on the tad. Ooh, boy. You guys better get on that. You guys have 17 days. 17 days of which to finish everything. So, it's enough of a tad. Okay. I'm gonna take your word for it there. I trust. Okay, I trust. Enough of a tad, that's fine. Alright, hopefully this stream will go smoother. At the temperature on my computer, it looks pretty decent, so now it's running much smoother. Alright, well that's okay. You know what? It is what it is, but you have 17 days. I just like the pressure of needing it to do it toward the end, but I'm spending the next 2 days focusing on homework. Wait, so hang on a second. That means you just like procrastinating and like having like all the work all thrown at you all at once, and then go into manic depressive states for like the next like 3 days. I don't know of anybody who likes that, but I mean, whatever floats your boat, I guess. I mean, okay. I ain't gonna tell you what to do, but that's all I can really say. I would just like you to put yourself in an advantageous position so you can pass. You don't have to worry about your grade. 10-page paper I've written or wrote the night before the night is due. I got an A. Look. Okay, here's what I gotta say about that. A 10-page paper, okay, a paper is subjective, okay? That is a subjective subject is English, okay? Completely subjective. If you write me a paper, I may or may not like it. I may read like 3 sentences, and I deemed if I read those 3 sentences or 3 words, then I'm going to slap a grade that I like, and that's an A. Fine. That's subjective. However, mathematics, on the other hand, is objective, right? Meaning you get it right or wrong. There's a right answer, there's a wrong answer. 2 different methodologies. Like I'm in your camp there, Elizabeth. I'll be like, okay, I wrote a paper that was due in high school. It was like a 2-page paper, 3-page paper. I had to write that. I didn't start on it until like 5:30 that same morning, and then I wrote it up and then turned it in at 8:30. So I've been there. Okay, I've had to write the BS. All right, I've been there, done that. Totally on board with what you're doing. Gotta be moved on with my life. Okay, I ain't gonna lie. Mathematics, a completely different animal about between that and subjectivity, subjectivity and objectivity. That's why I see like wait till last minute do math is kind of tomorrow's problem. That's what I said about my diet. It's always been tomorrow's problem. And believe me, it shows. Man. I'm like, today and every day is a cheat day. Sounds like a plan, dude. All right. All right. Hopefully, Lee Wen may join us here. If she's here, then go ahead and get started here. Saw someone else pop in. So, Lee Wen, you're out there. Then please say hello. So we can get going. I think. Yeah, we'll get going. All right. All right. Lee Wen is. Oh, maybe she'll come in a little bit. All right. When Lee Wen comes in, she'll be here. All right. In any case, let's go ahead and get started with today. We'll do some intros. We got some stuff to do. Let's go ahead and get started. Okay, let's get started today. Welcome back to Monday. Hope a nice weekend. All right. So for today, ladies and gentlemen, today we're going to be moving on here in chapter. We're moving here in chapter 6. Okay. Why my stream info did not revert. My stream info keep my. All right, hang on. We're doing 2 sections today. My stream info should have kept my stuff, but I'm gonna change that stream info there. All right. So today we're going to be doing 2 sections here once again from chapter 6. These are the last 2 sections here of chapter 6. Last time we did section 6.4, 6.5. We did again integration by parts. Okay, we went ahead and did limits of integration and that kind of stuff. So we kind of did 2 and 2 together there. And so now we're ready to go ahead and move forward here with the last 2 sections here, 6.6 and 6.7. All right, so let's go ahead and move forward here. Let's see exactly what we're working with. Okay. All right, let's take a look at the big board. Okay. So today, let me just point this out here for you guys. Question number 1 here is going to be section 6.6, and we have 2 more questions after that, 2 and 3, which will refer to section 6.7. Okay, but let's talk about question 1 here. Just going to go ahead and see exactly how that's going to work out. And again, we'll go through several examples here about how to find the area underneath the curve, depending on what we're given. All right, so how do we find the area between 2 curves? So in this section here, we are going to be given 2 curves here specifically, and we want to find the area between both of them. Now, the way we want this to work out is, let's take a look at step 1 here. Step 1 is to find out what the top curve is over the interval in question, or where the 2 curves intersect. You're going to determine which one is the top curve. And then step 2, find out which one is the bottom curve. And then step number 3 is really the formula behind how we go ahead and solve for the area between 2 curves. And that is, we take the top curve minus the bottom curve, all right, whatever those functions are, and then we just the integral of that from a to b respectively. Now, let's take a look at these first couple of examples here that you see here on the screen from the homework. Okay, we could do, which one I want to do? We'll do number 3 here to start with, and then we'll look at, I may look at, number 3 is a little bit easier. So, okay. So let's take a look at that one there, and let's go ahead and see how we can find the area underneath the curve between these 2 things. All right. So today I'm going to bring up my paint tool here. Let's see, you know what? I'm going to actually bring up I'm going to try my paint tool. It may break the interwebs, okay? I'm going to see if it likes it. May not like it. I'm going to roll with it, see what happens. Alright, it kind of likes it. Maybe. Okay. In any case, let's take a good look here at our first problem that we have here, and then we'll see how this works. Alright. Okay, so here we have number 3. So we have the area, we have 2 curves here, as you can see. We have one curve here, which is the square root of x, and we have another line here, which is x minus 2. Now, all I would like you to do here is to identify here, first of all, what our top curve is and what our bottom curve is. You have to look at the picture here carefully. What is the top curve here in this case? Which one of those 2 functions is going to be the top curve, according to the problem? Which one of those 2 is going to be the top curve? Is it going to be square root of x, or is it going to be x minus 2? Let's go ahead and type that out. You guys tell me which one will be the top curve here. The square root of x, right? Take a look at the curve here, right? It's going to be the square root of x. So this thing on top, although it's blinded by this stupid text box, but still, this thing that you see on top, that's going to be our top curve here. So that's going to be square root of x. That, by default, makes our bottom curve here. Our bottom here is going to be x minus 2. Okay. Now, if we follow this formula here carefully, okay, we're going to now take the, we're now going to go ahead and find the integral here. Now, the other thing I want you to keep in mind is look at this picture here very carefully. What 2 numbers are we going to use as our limits of integration? That's the question. What 2 numbers are we going to use here? So are we going to use, from what x value to what x value? What two numbers are we going to use? Take a look at the picture here. Again, they're going to be our x values here, by the way. Don't mind the y values here. Where do you guys think? No, not -2, not 2 and -2. You're looking at the y values, Emma. I want you to look at the x values. We're looking at the x values from what number to what number. Well, let's try again. So from what x value to what? 0 to 2, that's close. I'm going to have to agree with 0. What x value does it go out to? So 0 is out here. Right, it goes out to 4. That's correct. So from x equal to 0 to x equal to 4 here in this instance. Again, need to look at the x values here specifically. So I am going to put this down here as a good note because I think a point of contention seems to be at that note. You are looking at the x value. Okay, that is it. You're going to go from one value to another. Again, it'll be x values only that you're going to be looking over. Okay, nothing more, nothing less than that. All right. Okay. Now, having said that here, what happens after that? Well, what happens after that is we follow our little formula that we have here. Again, we take the top curve minus the bottom curve. And again, we have to put it together in one function. Notice that these are brackets here. These are put there on purpose. That way we are grouping them together. So we're going to take our top curve here, which is the square root of x, minus our bottom curve, which is x minus 2. And notice, I want you to recognize here that this is in parentheses, this x minus 2. Okay, that is important here. Okay, so I haven't neglected that at all. It's very important here because, again, why is that important? Well, because of the fact that we're going to distribute this minus sign here to both of these terms at the end of the day. All right. All right, so what do we got here once we put these pieces together? We have the integral here from 0 to 4. Okay, now the square root of x here is going to be x to the 1/2. And then we have minus x plus 2 dx. Okay. So we're going to go ahead and take the integral of all that. Okay, every single guy. All right. Actually, check something here. Check my. Okay, good. CPU is running not at 100. All right. All right. All right. Making sure that it doesn't crash again on me. Okay. So let's take a look here at the integral. The integral here is x to the 3 over 2 over 3 over 2. Okay. The integral of minus x is minus x squared over 2. And then plus 2x. And we're going to evaluate that from 0 to 4. Okay. All right, so let's see what we get here, each of them, and we'll find out together. All right, so we're gonna plug in 4. Let's plug in 4 for the first part. We get 4 to the 3 halves over 3 halves. We're gonna basically plug this in a calculator and we'll get. So we're gonna get a value here. Whatever that value is, it is what it is. 4 halves divided by 2 plus 2 times 4. And then this will be minus plugging in 0. But if you plug in 0 into everything on that right hand in that function, you'll just get 0 back. So that's 0 minus 0 plus 0. So it effectively will nullify everything. Okay, now if we plug this in appropriately here, what is that going to be? Let's see. This is 4 to the 3 halves is what? What is that going to be? 8? Yeah, that's 8 over 3 halves. So that's going to be 16 over 3. Again, you could use a calculator to find out this rest of this stuff here. So I'm doing this from memory. You do not have to do it by memory like I do. So I have 16 thirds minus 8 plus 8. And then these two basically wipe each other out. So that should leave me with 16 over 3. Okay. And so there you go. That is going to be our answer for this problem. All right. Good stuff. Okay. And so let's go ahead and try it out on our thing here. Get 16 over 3. Let's go ahead and try it out. And we got it. Perfect. Okay. That's correct. Any questions about that? Hopefully that one was not too bad. Pretty straightforward. At least I hope so. Okay, let's move on. Let's go to the next one here. Next one here will be one of these. Let's see, which one? All right. So you get your pick between, let's see, 4, 5, yeah, so let's have you pick between 4, 5, 6, 7. Sure. Actually, man, a lot of them actually. Yeah, let's just go with that. 4, 5, 6, or 7. You guys pick. 4 through 7. Pick one. All right. Do that as the next example. 4 through 7. One of those guys. So, and we'll just run with that. Which one do you guys want me to do? Do you want me to do 4, 5, 6, or 7? You pick them. Seven? Alright, you guys asked for 7. Let's do number 7 then. Why did my chat Okay, anyway. Alright, whatever. Alright, in any case, let's do number 7. Let's see what we get. Okie doke. Okay, so for number 7 here, let's go ahead and take a look here at the problem at hand. Alright, so number 7 says sketch the graphs of the functions f and g. So it gives us two functions here, specifically for number 7. First of all, f here is equal to 9 minus x squared. Okay, and the other one here is g of x, which is going to be 2x plus 3. Fine. So f of x is 9 minus x squared and 2x plus 3. That's fine. All right, so what we have to do is we have to go ahead and find what these two curves look like together on the same graph. Now again, let's go ahead and open up the calculator here. We can use the calculator, just simply do this without too much effort so we can determine which one of these pictures. Again, just like the last example, we do want the picture here. It is going to be very helpful. If we don't have the picture, that's fine. You can find out where they intersect. That's not a problem. It's just, in my estimation, it's just a bit easier. So, let's, wow, that is much bad. Okay, that's what I want. All right, so go to y equals. We'll go ahead and enter in these functions. 9 minus x squared. All right, we have 2x plus 3. All right, and we'll go ahead and graph these. All right, we don't have the best graphs, so we'll try and fit it. Fit. Okay, we have a pretty good idea about what this graph is. Again, if you don't know what this looks like, you can always zoom out. Maybe you want to get a bigger standard. There you go. A pretty good standpoint about where graphs are. Okay, so the real question is, which one of these, A, B, C, or D, which one of these is, we'll go again, A, B, C, D. Which one of these would be our match to our graph that we have on the calculator? Which one of these would be a match? Would it be the first one, second one, the third one, or the fourth one? What do you guys think? Which one is our match? The first one, second one, third one, or fourth one? Hmm. The first one. Okay, Elizabeth says the first one. All right. Number 1, good. Very nice. That is correct. Okay, the first one is correct. Away, where you notice it goes through 3, 0 and minus 3, 0. The fourth graph looks similar, but unfortunately it does not go through both of those points. So that's a dead giveaway. Obviously the other two are just not even the right direction. So let's go ahead, and we're looking in between two particular x values. So it says to find out between -3 and +1. That's what they tell us in this problem. Find the area in the region enclosed by those two values. Fine. All right, so we're not looking where they intersect. They give us these values here specifically already. They ask us, hey, just go ahead and figure it out. I said, okay, no problem. Let's go ahead and see what it is. All right. So let's first determine, though, what our top graph is and what our bottom graph is. So what is our top graph here in this case? So according to the picture here for letter A, or this first one, what's our top graph? Is it going to be F or is it going to be G? What's our top graph here? 9 minus x squared. Okay, good. So our top graph here is indeed 9 minus x squared. It is the parabola. That's correct. All right. Very nice. So our bottom graph here specifically is going to be 2x plus 3. Okay. So now that we know that, let's set up our problem. We know for a fact that it's going to be here from negative 3 to 1. And here we got 9 minus x squared, again in parentheses, minus 2x plus 3. Okay. I'm going to combine these together. And again, take the antiderivative slash integral of this. Okay, so we have to distribute here. Get 9 minus x squared minus 2x minus 3. What we have here is we have, take it one step here. So we got 6 minus x squared minus 2x. Okay, 9 minus 3. And then we just take the integral of that. And that's actually pretty straightforward. So let's see what we get here. We get, sorry, we get 6x minus x to the third over 3. Now 2x is basically 2x squared over 2, but the 2's cancel out, so that just leaves you with x squared. So the answer to 2x is just x squared. All right, so just showing off how you actually go ahead and find that. Now we evaluate that from negative 3 to 1. Okay. Now we're going to start off at 1, and then we'll plug in negative 3, and that's going to be a different story. So not an automatic 0 in this instance. So we have 1 squared. Okay. That's the first one. Now we want to plug in negative 3 into the second one. That. So 6 times negative 3 minus negative 3 third over 3 minus negative quantities. Okay. So this is what we have here so far. I didn't actually make. Okay, let's go ahead and figure out what these values are going to be, and you guys can figure them out with me. 6 times 1 is 6, minus 1/3, minus 1. Minus, let's see what we got here, minus negative 18. Negative 3/3 is minus 27. Minus 27 divided by 3 is minus 9. This becomes plus 9, negative. All right. And then we have minus 9 here. All right. Have that. Go. Okay, so what do we have here? 6 minus 1, which is 5. 5 minus 1/3, which is going to be 14 over 3. Okay, so here we get 14 over 3 minus a negative 18. Cancel. That's going to be 14/3 plus 18. So that's 54. That's 68 over 3. Going to be our answer for this problem. So 68 over 3 should be our final answer for this particular problem with these numbers in place. Let's test it out, and let's see if indeed we got the right answer. All right, and we got it. 68/3 is correct. All right, good. Let me go back to the work here for that. Yep. Sorry, I skipped over that work really fast, so I want you to take a look at it first. All right. Any questions about that one? Ah. I hope that was pretty clear. But I hope that at least for integration, that has been a little bit easier to maintain. Yeah, of course, Elizabeth. Yeah, ask me anything, guys. Ask me anything. Ask me absolutely anything. Do you want me to scroll up a little more, or is that okay, Elizabeth? I can zoom out as well if you want. I can zoom out like this, and then hopefully that'll be a bit easier for you. Okay, cool. So as you can see here, we identified both functions. We identified the top and bottom function. It gave us some numbers to play with. They say, here you go. Said, okay, that's great. And then we went ahead and did that integral. No problemo. Easy peasy, lemon squeeze. All right, any more? Hey, Li Wen. Hey, Li Wen finally connected. Is there something wrong with the internet? Your internet is unstable today. Oh, okay. That makes sense. Well, hopefully your internet is going to be okay. I made some tweaks to the stream, so but I tried to make the stream a lot more accessible. Yeah, I'm on 720 60 FPS, so 60 FPS seems to be the way to be. I know I was at 50, but then I lowered the bitrate too to make it a bit easier to connect, so hopefully that isn't an issue. If it is an issue for some people, because it can be, depending on what device that you're using to access the stream, then I can always lower the bitrate again next class, so or lower the FPS as well. I can go down to 30 frames if necessary. So, is it necessary? Maybe not with today's technology, but still, everybody's got different internet, so. All right, let's do another example. I think another example certainly is play. So, 8. 9 is a problem you guys can try on your own. 10 is a 10 is a different 10 and 10 is easy. 10 is pretty much the same exact problem that we. Yeah, that's not really. Okay. Let's go ahead and try number 8. Let's try number 8. All right, so we'll try the very next one here. All right, and so we have square root of x and negative 1/2 x minus 1. All right, let's take a look at that. Oh, sorry, wasn't what I wanted to. on the paint tool. Alright, let's wipe this away. Alright. We have two functions here specifically. We have f here, which is equal to square root of x, and g here, which is equal to negative 1/2 x minus 1. Okay. So that's what we have going on here. Now, of course, one of these has to be correct. All right, without question. All right. So let's again. Oh yeah. Okay. We have to find the area of the region enclosed by these graphs and the vertical lines of x equal to 1 and x equal to 4. So x equal to 1 to 4 of between these two guys. All right, so that's what we got to go find. So again, what we have to do here is okay, that was probably a joke. All right, I thought that was somebody. All right, now what we're going to do here is we're going to look at the calculator here once again. Okay, I accidentally messed it out, so again. All right, let's look at that and see what we have. We're just going to enter in these two functions here specifically that we see here, and we're going to see which one of these it matches. All right, so let's do this. Y equals, we'll hit square root of x, and then we'll hit negative, put that in parentheses just in case, negative 1/2 x minus 1. Graph it. All right. I'll fit this in. Number 8. Oh, that. I know which one it looks like. All right. Yeah, that one's over. All right. So let's take a look here at this. Now, which one of these graphs is it going to look like? Is it going to look like the first, second, third, or fourth? First, second, third, or fourth? What do you guys think? Which graph do these resemble? So which one of these would be your winner? Would it be the first, the second, the third, or the fourth choice that you see there? So we'll just go from the top here. 1, 2, 3, 4. Oh. Number 3. Okay, so Elizabeth says number 3. Okay. Let's see what others have to say. Number 3. I mean, we could zoom in a little bit if you'd like. Number 2. Ah, yes. See, there you go. Yeah, this one was a tricky one. Yeah, this one, admittingly, I admit it, guys. This one is a tricky one. Okay, it's 2, right? It looks like that they cross over and they intersect somewhere, but in actuality, if you zoom in, it actually doesn't. So this one here, a little tricky, I'm not going to lie. So just to be on the safe side, if you see these type of examples, just be sure on the safe side there that they do indeed intersect. Because obviously, your choice is between 2 and 3. The other 2 don't count. So yeah, that's absolutely correct. Again, you got fooled the first time, totally understandable. Just be sure to zoom in so you could possibly see that in this case there is a definite degree of separation between graphs in some variety. However, The approach that we're going to take here is no different, okay? Just because they don't intersect, it doesn't mean that there's no area. There's still going to be a top curve, and there's still going to be a bottom curve. That's still not going to change, all right? So they may not cross with each other. That doesn't mean there's no area because they don't cross with each other, okay? We are given two specific values here from 1 to 4, okay? So I am going to point that out here because that is important as part of this problem. But we first need to identify our top curve and our bottom curve. What's our top curve here and what's our bottom curve? Let's at least identify that before we move forward with anything else. What's our top curve and what's our bottom curve? Square root of x is the top. Okay, good. That's correct. That makes the other graph, by default, the bottom. Okay. So again, notice I'm just taking these steps here. I'm saying I got to first determine what's my top function, what's my bottom function. Okay, I'm being given some numbers here to work with, sure. But it's always the top and the bottom. Okay, yeah. All right. So, okay, good. Good. Okay, I like where things are going here. All right. Sounds good. All right, so now we're going to use our guy here. Again, we're given two specific values here. That's given from x equal to 1 to 4. So we're going to go 1 and 4. That's the two values we're given for x. And we're just going to go ahead and do our regular old rigmarole. Square root of x minus the quantity of 1/2 x minus 1, right? And let's go ahead and distribute the integral here from 1 to 4 of the square root of x plus 1/2 x plus 1, right? Again, the square root of x is x to the 1/2. Okay. Why does the integral only go to 4? That's the numbers that they gave us, Elizabeth. So let me zoom in on this problem here. You'll see it right here. Those are the numbers that are just given to us. So yeah, that's just. Yeah. No problem. Whatever numbers they give you in the problem, that's what you're just gonna run with. So yeah, don't worry about like it. Like I said, where it intersects, it doesn't matter. They're just gonna give us two numbers. They're like, okay, just find out what this area is. I'm like, then they're like, okay, fine, I'll just do whatever. So that's basically where we're sitting at. All right, so we have x to the 1/2 here. Again, that's square root of x to the 1/2. So here we get x to the 3/2 over 3/2. Just as usual. We have 1/2 x. 1/2 x is again going to be 1/2 x is 1/2 x squared over 2, which is going to be 1/4 x squared. Okay. So plus 1/4 x squared plus x. And we're going to evaluate that from 1 to 4. Okay. Okay, so let's plug in our two numbers here. We'll plug in 4, and then we'll plug in 1. So we'll start off with 4. We have 4 to the 3/2 over 3/2 plus 1 plus 1/4 times 4 squared plus 4. Then you're going to subtract that from the 1s. So let's put this on this second line. Get 1 to the 3/2 plus 1/4 times 1 squared plus 1. Okay. So far, so good. Okay. Now we're going to take a look at both parts here carefully. Take a look. First, we have 4 to the 3 halves. It's going to be 2. We got 8. We have 16 over 3. So let's break it down. 16 over 3 here. 4 squared is going to be 16 divided by 4 is 4. Fine. Plus 4. Okay. Fine. And then we have minus, and then let's see what we got here. We got 1. So 1 to any power is 1. So that's fine. You don't have to worry about that. Divide by 3 halves. Divide by fraction. You flip that over. That becomes 2/3. Okay. 1/4 times 1 is 1/4, and then a 1. All right. So 16/3 plus 8. That's going to be 24. It's going to be 40. We get 40 over 3. Again, you can use a calculator. I'm just doing this from memory. So, just because I don't have the calculator out, I'm doing my head. Is that 8? That's 8. That's 3, 11. 11 plus 12 is 23. Okay, so we get 23 over 12 here. All right. Yeah. We get 40 over 3 minus 23 over 12. And so let's see, what is that? 40 times 4, 160. 60 minus 23 is going to be 137 over 12. I think I'm doing this right in my head. So feel free to correct me if I'm wrong, by the way. So I don't mind if you, again, if you correct me because I'm wrong, then okay. So I get 137 over 12. Let's see what happens. Why not? 37 over 12 here. And that. And that's correct. Okay, 137 over 12 is the correct answer. All right, fine. Good, good. All right, wonderful. All right, that works. All right, any questions about that? Let's see if you guys me this. I have to zoom out a little bit. Okay. Is that better? I don't know if I should zoom in or zoom out or keep it like this or just zoom in a bit. There we go. No? Okay. Again, I just want to make it super clear about how we came up with the answer the way we did. So, still ended up with an answer. So, again, most of this numerical work, again, just go through it one step at a time. Okay, don't try and do all the numbers. Don't try and add all the numbers all at once. Sometimes it's easier, like I did it here, where I'm breaking it down one number at a time, and then putting everything together at the end, where then I get my actual sum. Because after you get to this point here, like 16 over 3 plus 4 plus 4, then it's like, okay, now I can easily put that together. I don't have to worry about that. I can just get rid of the messy parts here first and then put it together at the end, where it's much more palatable. So that's basically what I'm after there in that regard. Okay. All right. Good stuff. Okay. So that is going to be that there. Let me see if they're not. Right, so there's that problem there. Okay, so that one there is just basically, yeah, that one there is just basically. So for this last one here, I'm just going to let you know about this last one here, the word problem. Word problem is just you're taking the first function here, subtracting it from this second function. You're taking the top function minus the bottom function here, and you're going from 0 to 4, so within the next 4 years. So you go from 0 to 4, and then that's how you go ahead and solve for that. So basically, it may be a word problem, but really in the same similar vein that you have for this. Find out your top curve, find out your bottom curve. Go ahead and you can go ahead and put 2 and 2 together. Even the word problem there is pretty straightforward. That one there I'm going to leave to you to go ahead and do. Go ahead and give it a try because it works in the same vein as the previous examples. So find your top curve, find your bottom curve, go from 0 to 4, and then you're done. Simple enough. Uh, hopefully everybody is good with the integral here from 3e.3t. People good with that integral? I hope. People good with this integral here? Let me just ask that one last question there. Are people comfortable with this integral? Go ahead and put this down. Are people good with this integral? People know what the integral of this is going to be. So let me know yes or no if you guys know how to approach this particular problem if you're going to do the integral of this. This was the integration by parts. Just letting you know now, this was the integration, use substitution, sorry, not integration by parts, pardon me. Yeah, use substitution, integration by parts. This was the you guys comfortable with integrating what's on the screen? I hope so. But I'm just asking first. Do you need me to show you? Is the question. So either type yes or no in the chat there because I need to know. So okay, I could go over it. That's not a problem. That's why I ask. All right. So if we're going to do this, again, one of the things we talked about here earlier in this chapter is you could take this. Yes, you want me to go over this? Okay. All right. Let's do this again. So this 3 here effectively does nothing. You can bring this 3 on the outside here. I absolutely can do that. Yes, leave it. So here I have 3e to the 0.3t. I can bring that 3 on the outside. I'll deal with this 3 later if I need to use it. All right. What I need to do here first is to use some u substitution. So I'm going to have u here equal to 0.3 times t. All right. So if I do 0.3 times t, if I do du, du is here equal to 0.3 dt. So right now, as it stands, I have a 3 here on the outside. I have e to the u. I would like a du here, but I need to replace this dt part. But I have this 0.3 in my way, so I need to divide by 0.3 here on both sides. What I have here is I have 1 over 0.3 times dt. Okay? Now I'm going to take this 1 over 0.3 times dt. I'm going to bring that out to the outside. So this is what I have. 3 times 1, 1 over 0.3, okay, times the integral of e to the u du. Should be du, sorry, not dt. What's that? Okay, so I take the integral of this. I can take the integral of this, and so what I have here is 3 over 1 divided by 0.3. So you can put that in a calculator if you like. So 3 divided by 0.3. We can do that really quick. 3 divided by 0.3. So you get 10. You have 10 times the integral of e to the u du. So you have 10 e to the u. All right. And then just replace u again with whatever you defined it as, which was this. You get 10 e to the 0.3 times t. Okay. And so that's going to be your final answer for that one, if you're going to do the integral of that. All right. And then you'll have limits of integration that you'll take it over, of course. But you get the idea. So it came from two parts there, Elizabeth. It came from the fact that 3 was the number I put here on the outside to begin with. So I just brought that out to the left. And then the 1 divided by 0.3 came from the fact that I had to divide by 0.3 on both sides in order to replace dt with this du. So remember, if you got to do replacement here, you have to basically say, all right, I need to replace the dt with something in terms of du. Well, the only way I can get dt to work out is if I cancel out this 0.3 on this side and divide it on the other side. So that's why, again, to rewrite the same thing here, du over 0.3, another way to rewrite that is 1 over 0.3. Okay, 1 over 0.3 times du. Now that's, again, the same way you could write here du over 3 is the same thing as I could write 1/3 times du. Okay, I'm not doing anything different. I'm just rewriting it as something a little bit more palatable for me to go ahead and put together. All right. Yeah, so I'm just trying to break it down to be easy. So how do you know do you need to use substitution? So the easiest way that I knew how to use substitution is that I have an exponent here that contains a variable. So because I have e to some exponent that contains a variable that I can't easily do, I have to use substitution there. There's no other way around it. So that's one dead giveaway with e at the very least. Is like if I have a function, or if I have a function that's a derivative of another function inside the integral, I know I need to use substitution. Right? You think about how complicated it looks. You're like, if it looks pretty complicated and you can't use like the easy rules, Elizabeth, use substitution to see if you can break it down into something easier. You know, that's exactly what it's used for. All the examples that we did together in class when we did use substitution did did exactly that. As long as you can use substitution, you can go ahead and use it, because again, there's no other way around it outside of that. So that's why I did a lot of examples with that, because I'm like, oh, it's kind of a thing. So it's not not as straightforward. Can I tell a rude poem? Okay. I don't even know why that's even a question. Any other questions before I move forward? That was a good friendly reminder for things that has to happen. So things that must happen, part one. Things that you'll have to get to know for this exam, part one. So part one, two, and three. Yep. Oh, all right. Okay, we're gonna go ahead and move forward. All right, Nick, if you have any questions, just let me know. Okay. Um. All right. I'm gonna move on to the next section here. All right. Let's look at the next one. Okay. All right. So the last section here talks about two important concepts here when it comes to business. All right. So we talk about business, at least in this particular section, specifically to now that we know how to work with integration. We want to go ahead and take a look here at how we can go ahead and do what's called consumers surplus and producers surplus. Okay, so there are two formulas associated with consumers surplus and uh, consumers surplus and producer surplus, excuse me. And I'm going to put these on the screen as you can see there right now. So if you need to write that down or take a screenshot, now would be a good time. Um, I'll go through it while you guys are doing that. So first of all, number two here talks about a consumer surplus. So what is consumer surplus here? CS stands for consumer surplus. This is equal to the integral from 0 to x bar. We'll describe what that is in just a second. Of d of x, which is the demand function that will be given to us here, dx minus p bar x bar. Now p bar here is the market price, and x bar here is the quantity you sold. Okay, so p bar being the market price, x bar here being how many of those particular items that you happen to sell. Going off the same vein here, producer surplus basically is reversing the consumer surplus around, but instead of using a demand function, because we're not talking about the people who want to buy that good, we're talking about actually supplying that good. All right, so it'd be p bar x bar minus the integral of 0 to x bar of the supply function here in that instance. Okay, so again, depending on which way we're looking at it, right? If we're a consumer, we're demanding an item. All right, if we're producing, we're supplying an item at the end of the day. Hence why you have two different formulas here in this instance. All right, but we're just going to go ahead and take a look at it, a few examples of each, just a couple of examples really. And there's only like 5 questions here, so there's not much to really do. Okay, but we'll basically see how this is put together. Some of them give you a market price already. Um, uh, the We'll do one example of which one do I want to do? Yeah, so we're gonna do one example of. Wait, this is. Yeah, we could just do number 5 actually, because that really just showcases pretty much everything I want to say. Because these just give you like specific prices that you can easily use. Number 5 just basically forces you to do both, and they force you to do it in a very specific way. So let's do that because it basically is just a little bit more involved. I think we could just boil it down to one example. Of so all right. In any case, let's go ahead and read this off here before we start. All right, so the management of Titan Tire Company has determined that the quantity demanded X of their Super Titan tires per week is related to the unit price P by the relation P is equal to 176 minus X squared, where P is measured in dollars and X is measured in units of 1,000. Don't forget about this here, by the way. Context is important here for money. Sometimes they may throw that in there where a unit of measurement is like in thousands of dollars, for example, or whatever the case may be, or thousands of units. Titan will make X units of tires available in the market if the unit price uh, is, and here we have P here, um, is 80 plus 1 half X squared dollars. All right. Determine determine the consumer surplus and producer surplus when the market unit price is set at the equilibrium price. Okay. I'm gonna take this a little bit slow. All right, but we're gonna reference, of course, these two formulas we see here because we'll need to reference both of these formulas to solve for this guy here for consumer and producers. Okay, so the first thing that we want to do here, first and foremost, let's at least arrange our data. Okay, so let's just arrange stuff here. All right, we have to use a demand function. We have to use a supply function. Okay, let's just throw it out there. All right, we got to use one of each. So fine. All right, so our demand function here is that very first function you see there. All right, is going to be 176 minus x squared, as you see the quantity that demanded here. What we have here, 176 minus x squared. Okay, and what we have here also is we have um, our supply function here, s of x, which is equal to is going to be equal to 80 plus 1 half x squared. Right. Okay. All right. Now, we are given a particular thing here. Now, to make this a bit easier here, we have to be given a market price, and we also have to be given how many hundreds of units that we need to go ahead and sell. Now, that may be a little bit tough. If you're given an actual market price, well, then it's actually pretty easy to figure out, what X is going to be. However, we're not given that here in this case, okay? Unlike these first three examples where you're given an actual number and you could just plop it in and find out what X is. In this case here, they ask us for what's called the equilibrium price. Okay, so let's look at the equilibrium price. Now, to basically make a simple statement here regarding equilibrium. Equilibrium price is just reflective of where demand and supply are equal. Okay. Where demand and supply are equal. That's the equilibrium price here in this instance, okay? I just want to point that out there because again, we need to find out where this is going to occur. What's the proper price and how many tires do we need to find for that's how many tires do we need to make and what should be the price of those tires based on, whatever is given. So essentially, at the end of the day, we're going to set both of these equations here for the equilibrium price. We're going to set both of those equations equal to each other here in this instance. Okay, so we're going to set here, we're going to set 176 minus x squared. We're going to set that equal to 80 plus 1 half x squared. If we're going to find out first these equilibrium, how many units that we will be using. Okay, then we'll be able to find this equilibrium price. All right, so these are both the price here. So, all right, so let's solve for x here first and foremost, and let's see what we get. So let's see, we're gonna add by x squared on both sides, and we'll subtract by 80. Fine. Here we get what do we get? We get 96. All right, 96 equals 3 halves x squared. Okay. What am I gonna do next? I'm gonna divide by 3 halves. Okay, let's divide by 3 halves. What is that gonna be? It's 3, that's 32. 64? Okay. So you have 64 here is equal to x squared. All right. Again, you could use a calculator here for 96 divided by 3 halves. You'll find out that will be indeed 60. We'll take the square root of both sides. And here we'll have 8 is equal to x. Okay. In this case here, we are not using plus or minus. We're just going ahead and taking the positive value since we only care about those positive values. All right. Okay. Right. Any questions so far about that? We found x here. I haven't found p yet, by the way. I'm going to find that in just a second. So, but before we do, any questions? Okay. No. Okay. Just moving through this one a little bit slowly. Fine. We could take our time with this one. So, um, okay. Now we're getting there here to solve for p. We're not quite there yet. We're almost there. So for x here, um, what we want to do is we want to take this x and plug it into any one of these two equations, okay, to solve for p, because that's what p is equal to here according to the original problem. So p is 176 minus 8 squared, for example. That's equal to 176 minus 64. This is equal to 112. So we have a p value here. We have a price value here of 112. We have an x value here of 8, or reflective of 8,000 units of tires. Okay, so all right, so that's what we have here so far. We have p is 112 and x is 8. So we needed to find these first. And again, the reason why we needed to find these first is because before we can do consumers or producer surplus, we need both the p and the x here in order for us to go ahead and solve for both of those. So we basically done the hard part here into finding out what those two values are. Okay. And the other problems, they pretty much just give you one of the values and you can find the other. This one here, because we're given an equilibrium, we need to just do a little bit more extra work behind that. Okay. All right. Now that we have that set and ready to go, all right, we have x is equal to 8, p is equal to 112. All right, we're going to go ahead and find out what consumer surplus, pardon me, and producer surplus is going to be. Let's go ahead and use our formulas now with the two numbers that we just found here. Actually, let me so first and foremost here, let's start off with consumer surplus. Okay, so how does consumer surplus work? Let's go back to our formula. Again, the integral is 0 to x of d of x minus p times x. Okay, that down. So let's first find the integral here. Again, we have x is 8, so we're going to take the integral of 0 to 8 of d of x, which is 176 minus x squared, okay, and dx. And then we're going to subtract that from 8 times 112. Okay. Or actually, I put that the wrong way, didn't I? I wrote that backwards. Should be 112. I put p is not 8, p is 112. Sorry, my bad. I know they're the same two numbers, but I want to put them in respective spots. So. All right. So here, if we take the integral here, we get 176x minus x to the third over 3, going from 0 to 8. Let's figure out what that is first, and then we'll subtract by that value that we have on the right. So let's put in 8. 176 times 8 minus 8 to the third, 3. All right, so what is that going to be? Well, I'm not sure about that one, so can't do everything. That's okay. 176 times 8 minus, and then we'll put, well, you know what? That first. Subtract by yeah, 176 times 8, 1408. So minus that by 8 to the third divided by 3. That as a fraction. So we get 3712 over 3. Okay, I wonder if they... Actually, let me check that really quick, guys. I'm going to see if they want a decimal for that. Do they want a decimal? Or are they round to the nearest dollar? Okay, so they do want... Okay, that's fine. So, okay, I'll put it as a decimal here. 3712 over 3. Right, so they give us that. And then, all right, fine. That's what I get. I guess I'll write that down. 3712 over 3. And then we'll round it to the decimal at the very end. Minus 112 times 8. Okay, let's put on the calculator there. So we'll put 3712 over 3. Oh, not 3412. Calculator. Minus 112 times 8. I know is less than that. And then we'll look at the actual answer. Okay, so we get 341.33. So 341.3 repeating, 33. Okay, or again, 341. So that's what we have here for that one. Let's see. Let's confirm that before we do the producer's surplus here. Let's just put that down. We have 341, I believe, ran to the nearest dollar. So let's just check that out. Oh, that not right. I do something. Okay, so the P is correct. The X is definitely correct. Did I miss? Check. Did I miss something? Let's take a check here. Maybe I did miss. Check my stuff here. 1 to 76x minus x to the third over 3, right? Yeah. Okay. I don't see a problem there. Let's try 342. Let me round up. Oh, okay. All right, so I know those two values are correct. All right, let me check that really. What else am I missing here? I don't think I'm missing something, unless I'm missing a sign. Should be subtraction. Let me check here really fast. Sorry about this, folks. I'm missing a sign, then I gotta look it up and see where I'm missing the sign, but should be out of place at least for this. Oh, okay, okay. I think I know what's going on. All right. Oh, right. Okay. That's my fault there. I totally forgot. Oh, yeah, 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 yeah. Okay, okay, okay. No wonder why. Okay. No, we have the problem correct. Okay. I just forgot. I forgot what I told you guys earlier. That's my fault. I just realized what my error was. All right, so this answer is definitely correct. Just with one caveat, of course. Let's go back to what we have here. So 341.33 is correct. Um, but with this, we're going to erase this. But remember, this is in terms of thousands. So we actually have to multiply by 1,000 here. All right, so that's really what was going on. So 341,330, I believe, is the correct answer for that. So let's see if that is correct, because we're in thousands of dollars. Is that not right either? Do you want it 333? Oh wait, I did that. I did three. Yeah, okay, sorry. I rounded in the middle and I did it like a dum dum. So it's 333. All right. All right. That should be $333. That's my fault there. Never round at the end. That's what I say, and then I don't do it. All right. So there we go. $341,333 because it's 341.33 repeating, and then we have to multiply it by that extra 1,000 because of the context of the problem here being times 1,000. So we get $341,333 as our consumer surplus. It's no wonder why I was getting that wrong. All right. Okay. Any questions about that? Any questions so far? We'll do the producer surplus here in the same vein, but first and foremost, we'll see if there are any questions about that. Okay. All right. Okay. We're going to go ahead and move forward then with the second half, which is the producer surplus. Let's use that, and let's see what we get for that. So producer surplus here. I'll show that off here on the. Are you one of those? Are you one of those people that gets like a headache every time it rains, Elizabeth? As I've had coworkers who are like that. One person, I had a coworker whose knee always hurt every time it would rain. Just like just this really just like when you would rain, it's like as soon as their knees started hurting, it's just like She would often talk about it's like, oh, my knee is hurting, it's gonna rain. You don't really feel it at all. Yeah, it's all those pressure changes. It's true. Let's do producer surplus here. Producer surplus here, we're gonna go ahead and take px minus the integral of 0 to x of your supply equation. Weather makes you sleepy. When it rains, you have to go to bed. Now see how it is. All right, so we're going to have here the price here, which is 112 times 8, uh, times the integral from 0 to 8 of our supply equation. Our supply equation here is going to be 80 plus 1 half x squared. So we're just going to do this the same way we just did the last problem. Again, just go through it step by step here. Again, this time I won't forget about the extra 1,000 here that we do have to kind of throw in there. Obviously, I kind of forgot about that and accidentally rounded, but this time I will not make that same mistake. All right, so in this case here, we get 896 for that one there. So we get 896 minus, and then we have to figure out this integral here. So we have here 80x plus 1. Okay, so this one here, just to show this off, here we get x to the third over 3. That's the integral of x squared. But if you can do 1 half times 3, so that would be x to the third over 6. Or again, another way of writing that would be 1/6 times x to the third. Whichever way you want to write that, that's okay. Either way, that has the same connotation. So we have 1/6 times x to the third here. All right. And we're going to evaluate that from 0 to 8. Again, 0 doesn't do anything, so that's not going to be a deal. But let's figure out this second part here. So here we're going to have 80 times 8 plus 1/6 times 8 to the third. Okay, we got 896 here on the left. What do we have here on the right? What is this little guy? 80 times 8, which is 640, minus, was that 64, 500. That's, you know what? Thinking too much. All right, so let's do that here. Let's do, probably I'm making this. Why do I make things so much more complicated than I need to like stop and go back again. All right, so let's just do 80 times 8 first. I know that's 640, sure. So 80 times 8 for certainty, that is 640 minus, and we have 1/6 times 8 to the third. So the 8 to the third here divided by 6, or whatever you want, put it as a fraction. We get 1664 over 3. Okay, put that down. 1664 over 3. We have 896 minus 1664 over 3. And we're going to figure out what that is. Let's do that. So 896 minus 1664. We'll leave that as a decimal here actually in this case. We also get 341.333. Get 341.33333. And then we'll multiply that by 1,000. Right, this time I haven't forgotten. So we'll multiply this by 1,000, thousands of dollars. And so here we end up with $341,333.33. Okay, or 341,333 since it's rounded to the nearest dollar. So in fact, when we did this here at the equilibrium price, we got the same answer here both cases. All right, so put that down. 1, 3. Okay, I did this right this time. Now what's wrong? Did I do something wrong now? What did I do? Okay, I gotta go back and take a look. What did I do? see. I have 80x plus 1/6 x to the third, right? Is that what I did? Let's see. What did I do? 80 times 8 is 640. That's right. I took the 640. Oh, I took minus. Oh, no wonder. Wonder that answer's off because I'm supposed to put plus instead of minus. Oop, that's my fault there. Let's try that again. 640 plus 8 to the third. See, look what happens when you put one wrong thing in. All right, let me do that again. All right, stop. Stop, brain. Brain, you got to stop doing dumb things. All right, here. I'm going to start again. Plus 8 to the third. 8 to the third. Struggle bus is real for me today. All right, there we go. That's a lot better. So what's that as a fraction? All right, 21/76 over 3. Okay. Okay, now that makes sense. All right. Because of that one sign change that messed me up. All right, let me place that then. Now, that was up. I use minus and that should. All right, so then okay, I was looking at no wonder why I was looking at minus. All right, this is 21/76 for 3, and let's put that on the calculator again. Now I'm actually going to put this split screen. Follow. All right, so we have 896 minus 21/76 over 3. Okay. So here I get 170.6666 repeating. I multiply by 1,000. So I get 170,666.66. So it would be 170,667 if we round up. Let's try that. Let's try 176,667. If it's not that answer, then it's going to be 666. So whichever way they want, but I think they want it to the nearest dollar. Let's try that out first. 170,667. And that's correct. Okay, so 170,667. Yeah, I accidentally subtracted in the middle of the process instead of added. I put addition here, I just subtracted on the calculator for some reason. Oh well, that's okay. Made that correction and we're good. All right. Any questions about that? Any questions at all? Sorry about the little struggles there, but you got through it okay. So this should be fine. All right. So that, in a sense, basically number 5, in a sense, that's basically going to be uh, the entirety of section 6.7 is just basically doing examples just like that. In the first 3 problems here for the homework, you don't need to find the equilibrium price. They give you already a market price. They give you P. You just need to solve for X once you are given a P. So that's all you need to do for that one is just solve for X if you're given a P. And then for 4 and 5, They basically ask you, hey, find an equilibrium price and then do exactly the same thing that I just did here, and you should be able to solve for those guys. If you have any additional questions about that, about this particular section, because I just went over one example, just let me know, and then I can easily do another one. But they should be pretty much straightforward, in all honesty. So, what are we doing next time? By the tomorrow, I have to remind myself here. Oh, okay. Okay. That's okay. Fine. All right. All right. So, oh man, I went the full time today. All right, sorry about that. Okay, so we are done here for today. Okay, let me give you a little bit of a preview here. All right, so just to give you a little bit of a rundown about what we're going to be doing here for the next, I just want to give you a class note here, I suppose. Okay, so the next section here is 7.1. Okay, now 7.1 will be kind of the last of the integration stuff that we'll be doing here. We're doing what's called integration by parts. So that'll be the last part there. Integration by parts can be a little tricky. I kind of debate whether integration by parts is as tricky as use substitution at times. But like I said, we'll go slow over that as well. And then after that, section 7.1 is the only section we're going to be doing from chapter 7. Then we're going to go right to chapter 8 after that, and we'll have 3 sections from chapter 8 that we're going to be doing. So it's going to go, after this section, it'll be section 7.1, and then 8.1, 8.2, 8.3. Okay? So I just want to give a little bit of a note about what, we're just going to skip the rest of chapter 7 and go straight to chapter 8. In which case, just to give you a preview here regarding chapter 8, chapter 8 is going to now go into derivatives again. So it goes more into derivatives, but derivatives of 2 variables. All right, so we deal with 2 variables as opposed to 1, 2 variable functions. It's really not too hard at all. It's actually really, really easy. I would say that chapter 8 is a nice, good way to basically end a course because of how simple the process is. At first it looks intimidating, but then you look at it, and when you note the trick that you used there for that whole chapter, you're like, oh, it's not as bad as I thought it was. So it really honestly isn't. So looks that way, but honestly not. All right, so that's basically where we're at here. We have 4 more sections, count it, 4 more sections to go for any new material. Okay, now we have approximately 1, 2, 3, 4. Okay. So we have essentially 11 classes after today. We have 4 sections. Now I want to pose a question to all of you here before we end off class for today. A very important question. Okay, so what I like to do is we're going to finish ahead of time here. Now, of course, what I do with the spare amount of time is I go over any and all questions that you may have over homework or whatever, and then we can go over those as necessary. The question really I want to pose to you is if you want me to do the 4 sections here within the next couple days, or do you want me to do like 1 section a day for 4 days? Or you want me to do like a couple sections in one day? What do you guys want me to do for these last 4 sections? Because again, if I finish it a little bit earlier, I'll have more time for review. But if you guys want to go a little bit slower, I can do 1 section a day for the next 4 days, and then we finish like next Monday, for example, with all the new material, and then spend the rest of the time on review. So it's up to you about what you want me to do, but I want to pose the question to you first. Before we head out here for the day, I want to be sure that want to ask you guys first about what you want. So Guys, tell me what do you think I should do here, or what would be best for you? You would say finish it earlier and have more time for review. Okay. Okay, so having it done in in that. So one section each day. Okay, so Emma is of the opinion one section each day. Okay. Finish it earlier. Finish early, I say, then go back and review it all. There's a lot I gotta catch up on. There's a lot you gotta do, apparently, about being a tad bit behind here. By your own admission. So, so three of you say we'll finish it earlier, and then one says one section a day. Okay, so I'm gonna have to go with the majority here. That's just how it works. That's just how I'm operating. All right, but I would say that way we have more time to go over some earlier topics we may have forgotten about or just need refreshing on. Yeah, that's fair. Look, yeah, that's exactly why I put out the opinion out there. Be like, you know what? There's advantages to both. There's advantages to both. One section in a day, would be like, say, hey, I can get used to this. It's not so bad. Or uh, but finishing it earlier does give you more review time over the previous sections. We can certainly talk about and go over. So, oh yeah, by the way, I totally forgot. Actually, I didn't forget. I probably mentioned it before, actually. So anything for the final here is from again, all the tests there. Remember, the practice tests are also on the practice tests are basically like the test questions. So again, if you need me to go over any practice problems from the practice tests, you can certainly ask as well. Okay. Just not the exact problem, though. I'll go over a similar type of problem. You'll have to figure out the rest on your own. Like I said, I'll be posting up the final here fairly soon, so. Are there any questions, any comments that you guys like to make in regards to that? Again, basically every class after we're going to be done is just going to be review, 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 and more review. So I know that you guys have a lot of questions. Anytime I've done review, I know some people come, some people don't. I know there's only 4 people that usually come here. But you know what? It doesn't matter. I'm going to be here. If it means I sit here for 2 hours answering homework questions, that's exactly what I'm going to be doing. I don't have any qualms about doing that whatsoever. So, because this is your time. So. All right. So if there are no complaints, then at least I hope not. Emma, don't hate me. Um. If there are no complaints, then that's possible. All right, we are going to end it off here for today. Okay, so next time we're gonna do section 7.1 and 8.1. All right, so that is the next 2 on the docket here. Does the final still have a practice one? That's a great question. The answer is no. Okay, so the practice, there is no practice for the final exam. Okay, there is no practice for the final exam, and the reason why, Li Wen, is because of the fact that all the questions for the final are all from the pool of questions from the 3 exams. Okay, so basically all the possible questions that could appear on the final will be from all of the 3 exams. So essentially, if you look at each practice exam, then you will actually see the pool of questions, and I'll be taking off a few from each of those and putting it together in a final. Okay, so that's why there's no practice one, at least in that instance. I do it that way because the final should be comprehensive, and again, it needs to be fair in that regard. So if I gave you a practice one, it kind of defeat the purpose, at least. Okay. All right. All right, everybody. Thank you so very much for coming on out here to the stream once again. All right, we'll be doing 2 sections here tomorrow, as was asked. All right. We'll see how far we get though with tomorrow. We'll see how far we get. We may just end up doing 1 section actually, because integration by parts can be a little bit heavy at times. So I'll go slow over that just to be sure. And then we'll see if we get through 8.1. 8.1's there's not a lot in there, so to be honest. So maybe we get through a couple sections. But 7.1 here for sure for tomorrow. All right. Okay. So that'll take care of it for today, everybody. Thank you so very much here, everyone, for being patient with me here today. I really appreciate it. Thank you so very much. I love you all for coming on here. All you guys, you know, you come out here every single stream, and I really appreciate that. The one thing I'm actually really sincerely happy about is that you're investing time in yourself. So very happy to see that. I hope to see all of you tomorrow, same time, same place, everybody. All right. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane, everybody. Hey, you got the timing down. Very good. She got it. Nice. There you go. Thank you. Thank you so much, everybody. Have yourself a wonderful night. All right, everybody's have a great one. Take it easy. We will see you later. Bye. Bye, everybody.